In this video, we will talk about individual differences and heritability in general and specifically as they apply to dyslexia. Let's start with the general notion of individual differences. Imagine a simple example of how long it takes to run 100 meters. So if we would ask everyone in the population to run 100 meter sprint as fast as they can. So someone might take 20 seconds if they're somewhat athletic. Someone might take 1 minute if they're old and frail. And we can place each person at the point of the time that is measured for their run. And we would end up with something like this. This looks like a mountain in that there is some range of performance, which is how long most people take. And there are some who are doing much better than that, and some who are much slower than that. And the shape of the curve that we tend to get in these kinds of skill measures is called a bell curve, or can be transformed to look like a bell curve, otherwise known as normal distribution. The point is just that there is a wide range of performance, and most people are concentrated at some middle point in the range, which is average performance, and some people are farther from that average. Now, obviously, if you have this shape, some people are going to be very good, and some people are going to be not so good at all. When it concerns sprint running, what we might do is we might pick the really good ones and train them for a competitive team. And we wouldn't really do anything with the rest. If it concerns something like singing, again, we'd expect some people to be much better than average, some people to be much worse than average, and most people to be around average. In a situation like that, you might pick the really good ones and ask them to join the choir and provide them opportunities to become singers. When this kind of measurement or performance assessment concerns reading and writing, things are a little different because unlike running or singing, there is a social pressure to be literate. Actually, everyone has to be literate to successfully navigate development in our society, in our Western literate societies. So this pressure changes the weight that we place on these extremes. And instead of looking at these guys that are really good at reading and writing, it forces us to instead look at these guys. We apply the label dyslexia to the low end of the distribution of reading skill. We just call them dyslexic because of their poor reading and writing performance, and we seek to support them with special intervention, at least throughout the school years. In other words, the combination of normal individual variability, like that seen in every domain of skill, plus a specific cultural context of universal literacy, so these two things together lead to the existence of dyslexia, of the educational problem of dyslexia. This doesn't mean that dyslexia doesn't exist. Of course it does. People who can't learn to read do exist. Every teacher knows it. And the existence of this and the necessity of treating this as an educational problem results from these two factors taken together. So individual variability is key here. And it is also the basis for understanding what heritability means and how that relates to dyslexia. So what is heritability? Let us imagine again our population. Our population, and this is performance assessment on some skill, any skill. Can be running, can be singing, can be reading, can be anything we like. There is going to be a distribution of performance if you measure the whole population. And this will be true for the generation of parents and the generation of their children after they grow up themselves. So these aren't kids, although they are the children of these. So here is one generation at a given age, and this is their children, so the next generation at the same age. Can we predict the performance of children based on the performance of parents? The extent to which the answer to this question is positive is what we call heritability. Let us see this a little more clearly. So imagine one person here in the parent generation, and this person is slightly above the mean for their generation. So they're a little better than average. What can we say about their children, about this person's children? Are this person's children going to be on average? Do we expect them to be around here? Or do we expect them to be better than average, like their parent? These are the two situations. In one situation, we cannot predict performance of children by performance of parents. So the average performance of the two generations is the same. This is the case for a skill that has no heritability. In another case, the expected performance for the children of a person who is above the mean for their generation will also be above the mean. In the second case, we can predict, not perfectly, but with some degree of success, that the children of someone who performs above average will also perform above average for their generation. We're predicting a shift in the expected performance based on this person. Likewise, the children of this person would be expected to have lower than average performance in agreement with their parents, lower than average performance. And this would be the situation when there is heritability in the skill that we are considering. Another way to think about this is to consider the relative standings of two people. Here are two individuals in the parent generation, and here are their children. And we see that in this depiction, the person colored blue, who is the parent of the person colored blue here, the blue parent performs better than the pink parent, but in the children, the blue child performs worse than the pink child. In the other situation, we have the pink and blue parent in this order and the pink and blue child in the same order. So in this case here, the relative performance of the children is different, is the opposite order than that of their parents. But here, the relative performance of the children is the same. They're in the same direction as their parents. When the skill is heritable, this situation happens more often than this situation. And this is essentially what it means for a skill to be heritable. A skill that is perfectly heritable results in this situation always being true. This is hypothetical. Nothing is perfectly heritable. But theoretically, perfect heritability means that for every pair of parents, their children will have the same relationship. So if parent A performs better than parent B, the child of parent A will perform better than the child of parent B. And that is regardless of the overall level of performance of the whole distribution. It's all about relative standings. In a skill that has zero heritability, I don't think any such skill actually exists. All skills are to some degree heritable. So this is also a theoretical question. But in a skill with zero heritability, these two kinds of outcomes will be equally likely. So if we consider all possible parent pairs, in half of the cases, the children will be in the opposite order, and in half of the cases, they will be in the same order. This means that if there is zero heritability, and you have two parents, and you know which parent performs better than the other one, this does not help you predict with any success at all whose children will perform better. That's zero heritability. If you have perfect heritability and you know which parent performs better, then you know for sure which child performs better. It's the child of the parent who performs better. In actual skills measured, heritability is between these extremes. So if you know which parent performs better, you can guess that the child of the better performing parent will probably perform better, but you will not guess successfully all the time. You may guess successfully more often than not, but not all the time. So the important thing to understand here is that heritability is a statistical concept. It's not a biological concept. Heritability is the degree to which differences are common between generations. And the way that is stated, because heritability is attributed to genetic factors, but that's the whole point of heritability. Heritability is because parents pass on their genes to children. So their children inherit their abilities on the basis of their genes. Of course, this is not perfect because the genes are expressed in specific environments. So you can't predict how good they will be in each skill, but you can predict to some extent that the children of better performing parents will be better performing than the children of lower performing parents. In Wikipedia, which phrases this very appropriately, we see that studies of heritability ask questions such as how much genetic factors play a role in differences, for example, in height between people. So here we're considering skills, not height. Height is an attribute, not a skill, but there is no change in the concept. The important thing is that this is not the same as asking how much genetic factors influence height in any one person. So heritability is not about how tall you are. It's not about how well you read or about how fast you run. Heritability is about how taller you are than someone else. Heritability is about how much better or worse you read or sing or run than somebody else. and how much this difference between you and the other person is related to the difference between your respective parents. High heritability means that your difference from another person is associated with the difference between your respective parents. So if we now consider a skill with a distribution and those at the high end and those at the low end, and if this, whatever this is measured, if this skill is heritable to some degree, as all skills are, then we expect that the children of the high performers will perform better than average, and the children of the low performers will perform worse than average. That's a straightforward implication of heritability. Now look what happens when we keep the threshold for calling these guys low performers. If we apply this threshold across the generations, then a whole bunch of the low performers kids will be called low performers because they will be below this cut-off threshold. But only a few of the high performers kids will be below the threshold. So your risk of being below threshold, if your parent was a low performer, is much, much higher. It's all this red area than the risk of someone whose parents were high performers. And if you think of this as a dimension of reading skill, and these are the people with dyslexia, now you see why heritability of reading skill leads to a high risk for dyslexia among children of parents with dyslexia. In general, researchers analyze heritability by attributing differences in individual skill. They're analyzing differences within a population by attributing them to three possible factors, three causes of difference. So one factor that is responsible for differences is heritability, which is called the genetic factor. This is meant to represent the effects of genes. One factor affecting differences between individuals is the shared environment. So this concerns consistent environmental effects. And a third factor concerns what researchers call non-shared environment, which is a euphemism for noise. This is the part that cannot be attributed to the consistent causes. So it's just dumped into E, which instead of being called noise, it's called non-shared environment because people still think there are some systematic factors there that we just can't see them. So heritability is a proportion of variation, a proportion of variability or variances or differences among individuals. Proportion means it can go from 0 to 1. What proportion of variability among individuals can be attributed to genetic factors, which is another way of saying what proportion of variability among individuals is predictable by variability in their parents' performance. Now, the reason we switched to say genetic factors instead of parents' performance, although it's exactly the same thing that we mean, is that the way these are investigated in research is not usually by correlating parents and children's scores, but is done by taking advantage of genetic similarities among siblings. So Most of this research is carried out on twins who share a known average percentage of their genetic material. So we can talk about proportion of variation that is attributable to genetic factors without needing to assess parents. And the other thing you need to remember is that any physical or psychological index, including all kinds of performance or skills or measures, is to some extent heritable. So it has to be between 0 and 1. It's never 0 or 1. It makes sense to ask how much, what proportion of variation on any given index, trait, skill, or measure is heritable. How much? And it also makes sense to ask, how is that heritability happening? What are the molecular mechanisms and then the developmental, neural, and cognitive mechanisms that account for this? But these are completely different questions. And when we talk about estimating heritability, this has nothing to do with studying biology. It has to do with estimating a proportion of variability that is attributable to genetic factors, in other words, associated with parental variability. Heritability is therefore a statistical concept, and it's actually a fairly tricky one because the estimates of heritability cannot be universal and stable. Remember, people differ on everything, and we try to account for these differences by genetic, environmental, and other unknown factors as proportions. So if people are in different environments, and if there are differential effects of the environments, then the estimates of heritability will differ. This sounds very abstract, but think of it in a different way. Think of differences in reading ability between children in a place where many children do not go to school because they have to work and school is not compulsory or whatever. Of course, there are going to be huge differences in reading skill, and most of those differences will be attributable to the fact that some children didn't go to school and so have no reading performance. Their reading performance is going to be very low because of the environmental systematic effect of not going to school. So the proportion of variability in that population will be, to a large extent, environmental. If you ask the same question in a place where every child goes to school and all schools are pretty good, there is essentially no environmental variability or very little. So children cannot really differ very much in their reading skill because of different educational experiences in a state where the educational experiences are fairly homogeneous. So then what is normal? In that kind of study, we expect to see much higher estimates of heritability, so much higher proportions of differences accounted for by genetic factors because the environment is so homogeneous. This means that the estimates are specific to samples and environments and do not generalize. It makes no sense to ask what is the general estimate of heritability for any skill. It also makes no sense to ask how much of a specific person's measure or value is determined by their genes, because that's not what heritability is about. It makes no sense to ask how much of your height is due to your genes and how much is due to your food. In the same way, it makes no sense to ask how much of your reading skill is because of your genes and how much of your reading skill is because of your school. That is a nonsense question because heritability is not about your level of skill. Heritability is about your differences from others, the extent to which you perform better or worse than others. That's what heritability accounts for individual differences across generations. Further on, there is no implication with direct relevance for education. So understanding heritability, knowing there is heritability in reading and dyslexia and everything else, changes nothing. You should still do your best as an educator with every child as you would without knowing anything about heritability. There is absolutely no implication. Although it is of great interest for research to understand the causes and trajectories of these differences, when it comes to practical implications, heritability doesn't have any, because there aren't any skills that are anywhere near close to 0 or to 1. Any educator already knows that children are not equal. They're not equal in propensity or in ability. Therefore, if you want to make their outcomes more equal, you have to give more attention to those who have greater difficulty. If you want to pay equal attention to every child, you will produce much greater outcomes in some children than others. This is unavoidable. And educators understand that because they see that every day in their practice and act accordingly. So when it comes to dyslexia, which is a relatively heritable issue because reading performance is relatively heritable, at least 50%, then educators and states at large need to make their own decisions regarding the cutoffs that they will apply for the detection and the measures that they will provide for supporting those that are most in need for developing adequate reading skills to be able to function in our literate society.